and supply functions. How do I find the equilibrium point? So the demand and supply. These are not the functions. I'm just giving you an example. And the supply. How do I find the equilibrium point? EP.
You just set them equal to each other.
Very good. So d of x, thank you. Who was that? Brianna? Somebody
Yes.
else? Yes, thank you very much. Good. So I have x squared plus 1 equals, can anyone give us this squared?
X squared plus 4.
4x plus 4. A binomial squared is a trinomial. Please remember that. So the first term squared plus 2 times the first times the second plus the second term squared. And since I'm getting weird answers, I'm going to change the 1 into, let's say, what am I changing it to? I'm subtracting from it 12. Good. So I simplify. I subtract 4 from 12, and I get 8 equals 4x. I can get number of units that is negative, so I had to make that change. So what is x?
Two.
Very good. But since we are asked to find the equilibrium point, the point has to have an x value and a y value. How do I determine the y value of the point? I have the x. Yes. So how much is 2 squared plus 12?
16.
That's it. That's our equilibrium point. And the last concept that we listed here is the piecewise defined function. As I said, we have so many examples done in the past. It's up to you. I don't think there is anything else. And reading from a graph, that's all. And of course, limits, right? So let's look at a limit. Limit as x approaches 1 from the left, from 2 plus x over x minus 1. When we're asked to find the limit, what is the first thing we need to do? Always. When I'm asked to find the limit, the first thing I do is always what? Anyone remembers?
Can't you try putting it in first?
Yes. Awesome. Who was that?
Sloan.
Thank you. Plug it in. Always. Good. So when I plug it in, where is the numerator going? Anyone? Everyone knows when x approaches 1 from the left, where 2 plus x is going. I'm sure everyone knows that.
3.
Awesome. When x approaches 1, where is the denominator going?
0.
0. So this is the issue I'll come back to this. Remember what we said. A number over 0 has one of these three answers. This, or this, or this. And this is our situation. We have a number over 0. So I have to choose 1 or 2 or 3. So let's go back now. Since the numerator is positive, let's find the sign of this. You can say sign of 0? Yes, in this situation. 1 from the left. Can you give me a number from the left of 1? Very close to 1, but from the left.
Zero.
0 is very far.
That would be negative 1.1.
Yeah. So if this is 0 and this is 1, 0 is very far away. I'm talking about a number from the left, which is like 0.9. 0 is very far away from 1. There are infinitely many numbers between 0 and 1. Infinite. Okay, so say it again. I'm sorry. So
0.9.
good. So what is the sign? Don't calculate anything. I only need the sign.
Positive. Oh, negative.
Yes. So then what will I choose?
Negative infinity.
That's it. Because I have positive at the top and negative from the denominator, so it's negative infinite. Awesome. What if, and I'll stop, what if I have 0 over 0? There is hope. I'm not saying the limit exists, but what you will have to do is factor and simplify. In that situation, you factor and simplify. That's it.